Example 5, identify flaws in experiments. So we're going to try to identify any flaws in the design of this experiment and describe how it could be corrected. So experiment. An electronics company wants to test using a new graphing calculator in whether a new graphing calculator increases student test scores. So they're trying to test something. That to me already sounds like an experiment, right? Um, so that means there should be a experiment group and a control group. So let's see if we can identify what's happening there. And what's their question? Their question is calc improve score, right? I kind of like writing these. Let me write it out a little bit here. I kind of like writing these like a caveman. Question: calculator improve test score? A random sample is taken. So random, that's good. Calculus students are in the experimental group are given a new calculator to use. So experiment group, calc students. And algebra 2 students in the control group are asked to use their own calculator. So in the control group we have algebra 2 students. Hmm. When given the same test, the experimental group scored higher than the control group. So experiment scored higher than control. The company concludes that the use of the calculator increases the test score. Well, let's see here. Well, if I were to give a math test to two different groups, calculus students and algebra 2 students, who would you assume would probably do better on the test? Ones who know more math or ones who don't know as much math? Probably the ones that know more math, right? So calc students, just like if you did it with algebra 2 students and algebra 1, think about where you were at back in algebra 1 and how much you know now. You could blow your algebra 1 self out of the water, right? Same kind of thing here between calculus and algebra 2. So, um, so a flaw, control and experiment group creates bias to support um, positive result. What's the fix? Half of the calc students and half the algebra 2 students given calculator. So think of it this way. Let me draw a little Venn diagram for you. The old way, calculus, algebra 2. In here, new calculator, old calculator. Doesn't work very well. New idea, old, old, new. This is the calc class. This is the algebra 2 class. So some kids in both the classes will get the new calculator. That way you're more comparing them to their peers instead of between different grade levels. That should fix the bias in this experiment. Imagine it this way. Imagine you had a PE class and they were all full of like the track stars and you had them run a timed mile versus the PE class where you play foursquare the whole time. Who's going to run faster? Probably the class full of track stars.